All right, so we are starting chapter 4, and chapter 4 is all about organic compounds. And I know you've probably heard the word organic before, but we're going to give it a scientific definition. You know, you went to the grocery store and you got some organic fruit or something like that. That's not the kind of organic we're talking about. That's like the common terms for organic. What we're going to talk about is the scientific definition for an organic compound. So this is a compound that has carbon and has hydrogen, but it also can include some of our other elements, especially those that are essential to life, like oxygen, nitrogen, phosphorus, sulfur, those kind of things can also be on it. But in order to be organic, we have to have carbon. If I can write, we have to have carbon, we have to have hydrogen. And so you're going to see that all of our biomolecules inside of our cells, inside of our bodies, are all organic. Proteins, carbohydrates, lipids, DNA, all that stuff is organic because it contains carbon and hydrogen. So the opposite of an organic compound is an inorganic compound that doesn't contain any carbon. And so we're not going to talk about those. Right? So let's talk about how we can represent inorganic compound. So you have to remember when you're writing these structures of these organic compounds that carbon, right, has 4 valence electrons. So when we write our Lewis dot diagram, we have 4 valence electrons around carbon. So what's carbon going to do? Carbon wants to make 4 bonds. So if you remember that, carbon wants 4 bonds. So for example, if we have CH4, right, carbon's going to bond to 4 hydrogens. And I tried to squeeze it in there. So carbon will bind there to 4 hydrogens. And so that makes carbon happy because it has an octet. Look, my video's over it. So we have an octet around carbon. So carbon's happy. But a lot of times, organic compounds become huge. They become really long and really big. And so if I were to go in and draw the Lewis structure of a lot of the organic compounds, I would be drawing for a really, really long time. And so we have a couple of different ways to draw and represent the structure of organic compounds. And so we can use what are called condensed formulas. So if I told you, right, our CH4 is a molecular formula. So it tells me about everything that's in the molecule, but it just tells me elements and number of atoms of those elements. So that's a molecular formula. Another example of a molecular formula is C3H8. Now, with CH4, we can't go into a condensed structure because CH4 is simple, it's just 1 carbon. But here, when we have C3H8, we can actually show the orientation of the carbons in the molecule and the orientation of the hydrogens. We just don't show bonds, and we don't show lone pairs. So when you switch from having a molecular formula, like what you do in a balanced chemical equation, now we're going to show a condensed structure. So it doesn't have bonds, but we do show where those hydrogens are attached, right? So this is telling me that first carbon has 3 hydrogens, the second carbon has 2 hydrogens, and the third carbon has 3 hydrogens. So it's not as much work as showing a Lewis structure, but it's better than just a plain old molecular formula. This gives us a little bit of information about how that molecule is structured. And then our final, most expanded is our Lewis structure, where we're showing all the bonds, we're showing all the atoms, we show everything. Okay, so you can go one more simple way to show an organic compound, and this is called a skeletal structure. So the skeletal structure, we call it the bare bones. So when you do this, you're only going to show bonds between atoms as lines. And you're only going to show them for carbon. So you're going to show them bonds between carbon atoms and bonds between carbon and another element other than hydrogen. So you do not show bonds to hydrogen atoms. So let's look at our example down here. We had C3H8. We showed its condensed formula, and we showed the Lewis structure. So what we do is we take this either condensed, Lewis, whatever you want to think about, and we say, okay, if I have 1, 2, 3 carbons, right? Here's my 1, 2, 3 carbons. This is my skeletal structure. All it is lines that represent the bonds that connect carbon atoms. We don't actually show the hydrogen atoms. They're there, but we basically assume that they're there. We don't have to show it because we know carbon always wants an octet. So carbon's going to be attached to carbon, and any other bonds are going to be to hydrogen. So we don't show bonds to hydrogen, and we don't show hydrogen atoms. It's a simple way to show molecules that can get really big. And so the more you practice, the better you're going to get. It's not so bad. So let's go over our rules. We're going to show any bond to a carbon. So like carbon-carbon bonds, you're going to show. If you had carbon to like a bromine, you would show that. But you do not show bonds between carbon and hydrogen. These are not shown, but they're implied. They're there. Any other element bonded to a carbon, right? We show it and we put its symbol. That's what I'm shown right here, right? So if these atoms, if you had another element here, bromine's not going to have anything attached to it, but if this atom had something attached to it, then the hydrogens are shown. So for example, I have a carbon and that carbon's attached to an oxygen, I would show the hydrogen. So if I had a chain of carbons, right? So maybe 3 carbons, I know I have hydrogens attached to those carbons. So this is like my Lewis structure. If I can draw in all my hydrogens. But what I have is 1, 2, 3 carbons. So I'm going to go 1, I'm going to go 1, 2, 3 carbons. And then I'm going to attach to my oxygen. So I have another bond to my oxygen, and I'm going to show my hydrogen there. Even though I know on those carbon 1, carbon 2, carbon 3, there are hydrogens, I don't show them in a skeletal structure. I only show my hydrogens that are attached to other elements. Now, when I draw this Lewis structure, if I look at my oxygen here, my oxygen is attached to a hydrogen here and a carbon here. It doesn't have a complete octet. So to draw a true Lewis structure, I would have to add in 2 lone pairs on my oxygen to get a complete octet. Now I have 2, 4, 6, 8. Now hydrogen's happy. But when I draw a skeletal structure, I don't have to draw my lone pairs in. They're assumed to be there. We're assuming that oxygen is always going to have 2 bonds and 2 lone pairs of electrons unless it's charged. And we won't talk about that yet. So when you draw your skeleton structure, you do not need to show lone pairs. Okay. All right. So here's one more example, right? Let's see. What do we have? 1, 2, 3, 4 carbons here. So it would be. So your book does this thing where when you're drawing these carbons, what they do is they say, okay, if I'm going to draw this, let me draw at least a ball, something to show that I have a carbon atom here. And it kind of does help you to understand where the carbon atoms are. So what I like to do, right, is I like to number them. I like to say that's 1 carbon, 2 carbons, 3 carbons, 4 carbons. Right? And then I like to come and double check when I draw my skeleton structure, 1, 2, 3, 4 carbons. Because sometimes when you start drawing, you'll miss one or you'll draw one too many. So you definitely want to number your carbons and go and double check. Now, when you do your final structure, don't leave it with dots. Draw one last final structure that is just lines, right? And so this would be my final structure. I have 1, 2, 3, 4 carbons, but I'm not going to leave my numbers. I'm going to take my numbers off. So this would be my final answer for my skeleton structure of this original molecule, right? Here's another example. Whoa. And so here I'm going to look and I have 1, 2, 3 carbons, right? But what you really need to pay attention to is I have this extra group right here, this OH group. So I need to make sure to add that into my structure. So I'm going to draw 1, 2, 3 carbons, but I have to be careful. There's something attached to that second carbon. So when you look at that second carbon, what you want to do is you want to add another bond to it, and you want to, whoa, oh, my iPad got stuck. No. Let's see. See if I can do this. Come on. There we go. We're going to draw in that oxygen and that hydrogen. So when you draw that, don't forget if you have a group attached to a carbon that you go ahead and draw it in. So when we can do our final structure, we're going to look like this. 1, 2, 3 carbons, right? But I'm going to erase that. I don't want to show my numbers. And I'm going to attach to that carbon an oxygen, and I'm going to show my hydrogen, okay? So that would be my final structure here. So let's go ahead and let's go do some other problems. Let me pause this and I'm going to switch. Okay, so here are in-class problems. I tried to space them out a little bit more and give us a little bit more room to work. So hopefully it won't be so crammed in this chapter. All right, we're going to do our odd ones. So we're going to start with 4.1. So describe the difference between a Lewis structure and a condensed structure in terms of atoms and bonds shown. So let's talk about both. Let's talk about Lewis first. When we talk about Lewis structure, the cool thing about Lewis structure is that everything is shown. So you have all atoms, you have all bonds, and you have all lone pairs of electrons. So you have all of everything, right? How is that different in a condensed form? When we talk about condensed form, we're going to show as few bonds as possible. So you're going to show as few bonds as possible, right? We're probably not going to show lone pairs. Sometimes they do. Sometimes they do. So I'll put that caveat. But usually, you don't show lone pairs, right? It just takes up space that you don't need because you can just kind of assume they're there. We're going to show in a condensed form all atoms. We're definitely going to show all of our atoms, but we're going to list those atoms, how they are in the actual molecule. So we're going to list them from left to right, how they are shown in the molecule, how they are maybe oriented in the molecule. And it's going to make more sense once we do some at the bottom, right? And so this shows the connection between atoms. That's why we want to list them left to right, because it's going to give us some more information about those molecules, right? Okay, so explain why it is not possible to draw a skeleton structure for methane. So if you go and you look in your textbook and you find out what is methane, you're going to find out that methane is CH4. If I want to draw the difference between a molecular formula, so this is molecular, a molecular formula, a condensed formula, and then a skeletal, S-K-E-L-E-T-A, skeletal formula. Your molecular formula and your condensed formula for methane is the same thing. So if I want to draw a skeletal, remember my skeletal is where I draw a bond between the 2 carbons. Well, I can't really do that because I don't have more than 1 carbon. So I can't draw a skeleton. We typically don't draw a skeleton for anything that is less than 3 carbons. So not used for less than 3 carbon molecules, right? Because if it were 2 carbons, it would be a stick, right? But at least when you get to 3 carbons, you go 1, 2, 3. And so that's your simplest skeleton formula. So if we went backwards, we said, okay, that's the skeleton. What's our condensed? Well, we're going to have a carbon, and a carbon, right? Now we have to make sure that each of those carbons has a complete octet, and we're going to fill it with hydrogens. So that would be CH. This carbon's only bonded to that carbon right there, but I'm not going to draw the bonds in a condensed. I'm just going to list them. So I'd have CH3. Now this carbon in the middle is bonded to this carbon and this carbon. So it only has 2 more bonds that it has to make. So it's going to make those 2 bonds with hydrogen. So I'm going to say CH, ooh, I erased it, CH2. This last carbon is only bonded to this 1 carbon. So it has 1 bond. So it needs to make 3 more to complete its octet. So this one's going to be CH3. And then if I wanted to say my molecular formula, I would say carbon. I know I have carbon atoms. How many do I have? I have 3. My hydrogen, I'm going to add up my hydrogen. I have 3, 5, 8. And that's my molecular formula. So this is the difference between molecular, condensed, and skeletal. Okay. Let's see. Draw a skeletal structure for each of the following compounds. And look how much room I gave y'all. Isn't that so nice? Okay, a skeletal structure. Remember when we talk about skeleton, this is the bare bones. So only carbon-carbon bonds and carbon, anything other than hydrogen bonds, right? So what I like to do first is I like to count my carbons. You want to count your carbons so that you end up with the longest number of carbons in a row. So if I went 1, 2, 3, that's not going to give me my largest count. So I want to count the largest in a row. 1, 2, 3, 4, 5 carbons. And so I'm going to say that this other carbon here, I'm going to have to add to my main chain. So I kind of highlight it just so that I know, don't forget to add that extra carbon. So I'm going to come over here. And I want to draw my skeleton structure. So remember, just bare bones, we're only going to draw our lines. So I need to have 5 carbons in a row. So here's my first carbon. I'm going to start with those dots, kind of like the book does. That way you know where those carbon atoms are. That's 1, 2, 3, 4, 5. So that's my main carbon chain, but I don't want to forget my extra carbon that's hanging out off of carbon 2. So I'm going to draw me a line and put me another carbon. But don't leave the dots. Don't leave the dots. So my real final answer for this one is just going to look like a bunch of sticks. That's what drawing organic compounds is, just drawing sticks. And then remember, off of that second carbon, so 1, 2, that second carbon, I have another carbon coming off of it. See? Okay, there we go. And don't leave your numbers on them. Take your numbers off. So here is my final answer for that one. Okay. All right, the next one. Count your carbons. 1, 2, 3, 4. Now be careful. You have a double bond right here. So we got to make sure that we include that in our structure. So let's try doing the ball and stick first, and then we'll go to just the sticks. So I need 4 carbons in a row. So I'm going to start with my first carbon. 2, 3, 4. Now I go back and check anything I highlighted on my original structure. And I see that I have a double bond. And so I'm going to add in another bond between these 2 atoms. Okay. So now I need to draw my real structure. I'm going to come over here. Don't draw in those circles. So remember, just sticks for the final. So we go 1, 2 carbons to my third carbon. See if this will work. To my third carbon, to my fourth carbon. Now, the way that we do this, so this is 1, 2, 3, 4. We have that double bond between the third and fourth carbon. So leave your sticks all together and then just add in another stick like that. And that tells us that there's a double bond between carbon 3 and carbon 4. But remember, don't leave your numbers. And that's my final answer. Okay, let's go down. That's for us to do in class. Here we go. Draw a Lewis structure for the following compounds. So now we're kind of going in reverse. We're given this bare bones stuff and we're told to draw something more complete, right? Okay, so what I like to do is I like to highlight what's different in this, right? And I like to number my carbons in here. So I'm going to number my carbons. I'm going to go 1, 2, 3, 4, 5 carbons. And then what do I have that's different? I have a double bond that I need to worry about. And I have a carbon coming off of this, I have a chlorine coming off of this fourth carbon here, okay? So how am I going to do that? Well, I'm going to start with my first carbon. Remember, this is Lewis structure. So I'm going to draw a carbon. And I'm going to first add in all my carbon-carbon bonds, and then I'll go back and add hydrogens. I think it's easier to do that. And I need a double bond between my first carbon and my second carbon, right? Okay, then I go to my third carbon, I go to my fourth carbon, and I go to my fifth carbon. But I got to go back. I got to be careful. I don't want to forget my chlorine. My chlorine's on 3, 4, 5. So it comes off of this one right here, chlorine. Now, I am going to erase my numbers because numbers aren't in Lewis structure. So I use them as kind of placeholders, but I don't want to leave them in my final answer. So now I'm going to draw in hydrogens in order to complete everybody's octet. I'm going to tell you, be careful if it's not carbon. Remember, carbon wants 4 bonds. Carbon 1 right here. This one has 2 bonds associated with it. So it's got 2 4 electrons around it. So 4 electrons is not enough. We want 8. So that's 2, 4. And then I'll do a hydrogen and a hydrogen. That gives me 8. So that carbon's happy. My second carbon here has 1, 2, 3 pairs of shared electrons. So that's 2, 4, 6 electrons. So that carbon needs 1 more hydrogen bond to a hydrogen in order to have a complete octet. Go to the third carbon. This third carbon has 2, 4 carbons, 2, 4 electrons, 4 electrons. So it needs 2 more bonds in order to complete its octet, and we're going to give them hydrogens. This third carbon has 1, 2, 3 bonds. So that's 2, 4, 6 electrons. So it needs 1 more bond to complete its octet, and we'll give that a hydrogen. The last carbon only has 1 bond. So it needs 3 more bonds. And I kind of painted myself into a corner there. So we gave that last carbon 3 hydrogens. The only thing that you have to be careful about is this chlorine right here. This chlorine, if you drew the Lewis dot structure of just chlorine, right? What would you do? 1, 2, 3, 4, 5, 6, 7 valence electrons. So if this one has 7 valence electrons, how many bonds can it make with anything? It's only going to make 1 bond with, let's say, a carbon, right? And I'm not going to draw what happens to that carbon. I'm just looking at the chlorine. So chlorine can only make a single bond. Don't put hydrogens around chlorine. You're only putting hydrogens around the carbon. And so if you wanted to include it, you could include the lone pairs on chlorine, but you don't necessarily have to. In the book, you're going to see that now in these Lewis structures, we're not drawing the lone pairs quite as much, but I think it kind of helps y'all to remember why you're not adding hydrogens to the chlorine. Okay, the next one. All right, I'm gonna count my carbons, right? I want my longest chain possible. So I'm gonna start 1, 2, 3, 4, 5, 6, 7. So every kind of point is a carbon, and the ends are also carbons. So what do I have attached to this main chain? Well, I got something right there, right? That's actually a carbon with some hydrogens on it right there. And then I also have a fluorine atom on that 4th carbon. So let's see how we're going to do that. See if I can scroll up, make myself some room. So I'm going to start with a carbon, right? So this is my carbon 1. It's going to be attached to carbon 2. It's going to be attached to carbon 3. Now I have carbon 3, and I want to go to 4. So see how it kind of came up? So I started up, and now I'm going to go across. So then I have carbon 4, carbon 5, carbon 6, and then carbon 7. And I'm going to go back and erase my numbers before I'm done. All right. So before you add hydrogens, go look at those highlighted things that you see are off of the main chain of carbons and put them in. So I know on that carbon 3, I need another carbon. Here's my carbon. This is carbon 3 right here. This like place where I see 3 bonds, and that's carbon 3. That's this one right here. And I see that I have just a stick coming off. So what that stick means is there's a carbon at the end there. So right there, there's a carbon. So I'm going to put my carbon right there. So now, what else do I have? I have a fluorine right here. I have my fluorine. So I need to go and add that to carbon 4. So I'm going to put my fluorine there. Okay, now that I've done that, I'm going to go in and add hydrogens to everything. So my carbon 1 only has 1 bond, so I need to put in 3 hydrogen bonds in order to complete its octet. Carbon 2 has 2, so I'm going to add 2. So if you kind of just remember, carbon needs 4 bonds, and whatever's not there, go ahead and fill it in with hydrogens. So my carbon here only has 1 bond, so I'm going to add 3 hydrogens. My carbon 3 has 3 bonds already, so I'm going to only add 1 hydrogen. Carbon 4 has 3, so I'm going to add 1 hydrogen. Carbon 5 has 2, so I'm going to add 2. Carbon 6 has 2, add 2. Carbon 7 has 1, so I'm going to add 3. And just remember with that fluorine is another halogen. And so if you drew the Lewis structure of just fluorine, 1, 2, 3, 4, 5, 6, 7, what you're going to see here is that fluorine can only make 1 bond with that 1 electron that's not paired. So you're going to put in the other lone pairs of electrons and see that you can't make any more bonds with fluorine. Okay, all right. And that one's for class. Here we go. Draw a condensed structure for each of the following. So condensed is not our skeletal, right? A, we're showing skeletal. So now we want to show a condensed form. So if we look at A, I'm going to number my carbons. I love to number my carbons. So I'm going to go 1, 2, 3, 4, 5. And then I'm going to highlight anything that's attached. So I see on carbon 2, I have an oxygen and a hydrogen. And then I see on carbon 3, I have a carbon. So what's really inside here is another carbon. Okay, so let's go ahead and draw that. So I have carbon 1. Oh, did I leave my 1s? I did leave my numbers. Don't leave your numbers. Get rid of your numbers. Okay, there. Now that structure is good. I don't know what that is. Okay, so be careful. Don't leave your numbers. But I think numbers are nice when you're first doing this. Okay, so I got to go 5 carbons in a row. Okay, so let me do that. And what am I drawing? I'm drawing condensed. So 1, 2, 3, 4, 5. I'm not doing Lewis structure. Lewis structure is different. I'm doing condensed. So this is 1, 2, 3, 4, 5, right? Okay, so what's coming off of these main chain carbons? Carbon 2 has an oxygen and a hydrogen attached to it. So I'm going to write it that way. And then we have on carbon 3, we have another carbon attached, right? So what we want to do is now go in and fill in hydrogens. But remember, this is not Lewis. If this were Lewis, I would do something like that, and I would put my hydrogens, right, to fill my octet. But this is not Lewis. I'm asked for a condensed structure. So instead of drawing the bonds, I still need 1, 2, 3 hydrogens attached to this first carbon. So remember that we need 3 hydrogens attached to that first carbon. And so I'm going to call this, let me get rid of my number, CH3. Because if it's on the end and it only has 1 bond to another carbon, you're going to have to add 3 hydrogens to it. Go to carbon 2. Carbon 2, if you look, has 1, 2, 3 bonds attached to it. So I'm going to have to just add 1 more hydrogen there. So I'm going to change that and I'm going to put 1 hydrogen, CH. I go to carbon 3. This carbon has 1, 2, 3 bonds. So I only need 1 more hydrogen. So I'm going to put an H right there. Now I'm going to drop down. This is my extra carbon coming off here. This extra carbon only has 1 bond to it. So I'm going to have to put 3 hydrogens attached to that 1 carbon. Go back up to my main chain. Go to carbon 4. Carbon 4 has 1, 2 bonds attached to it. So I need to put 2 more carbons. 2 more hydrogens, excuse me, 2 more hydrogens, so CH2. Then I go to 5, carbon 5. I have only 1 bond, so I need 3 more bonds. So that means 3 more hydrogens, so CH3. And this is my condensed structure. So my condensed structure does show me kind of the orientation of the molecule, where the oxygen's coming off of, where the carbon's coming off of, rather than a molecular formula. A molecular formula, I would just count up my carbons and say C, 1, 2, 3, 4, 5, 6. This would be C6, H, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I would say I have an O. Sometimes they'll put the H together and they'll go C6H14O, right? Either one would be fine. But these are molecular, right? Whereas this is condensed. That's the condensed structure. So be careful with molecular formula, condensed structure, skeletal structure, and Lewis structure. So we actually are showing 4 different things right here. This one is skeletal. This one is Lewis, right? And then the one that we just drew is our condensed form, okay? So now let's try to go from a Lewis to a condensed. And this one's, I kind of think this is a little bit easier. So we're starting with our Lewis. Let me try a different color. So let me count my carbons to get my longest chain of carbons. So 1, 2, 3, 4, 5. And I need to be careful of a few things. I have a carbon here, and I have an OH here. So I need to be careful to make sure to add those, all right? So when I go ahead and do that, I'm gonna draw my chain of carbons. 1, 2, 3, 4, 5, okay? Now I wanna add my OH, and it doesn't matter where you put the OH, you could put it at any one of the 3 places around the carbon. Does not make a difference. I'm going to put it coming down, right? And you actually have, it's actually bound to the oxygen. So kind of make sure that that line goes straight to the oxygen, right? Okay, and what else did I have to add? On my carbon 3, I have another carbon. So those are my extra things. Now I'm going to go in and I'm going to add my hydrogens. Ooh. So carbon 1, you could count, but you kind of already know, right? So I have 2 hydrogens, so that'd be H2. I go on to my second carbon, and I have 2 hydrogens, so this is CH2. Go to my third carbon. I have only 1 hydrogen because I have 1, 2, 3 bonds already done. So I'm just going to put CH because I only have 1 hydrogen there. If I look at that carbon that's attached to carbon 3, it's got 1, 2, 3 hydrogens. So this is CH3. Then I go to carbon 4. Carbon 4 has 1, 2 hydrogens, CH2, and the last one has 1, 2, 3 hydrogens, so H3. So this is my condensed structure, of this one. Okay, so it shows me the orientation of the molecules, but it's not as much work as a Lewis dot structure. So in the condensed, you can put those lone pairs on oxygen, because oxygen, if it's not charged, it's always going to have 2 bonds. So we have a bond to the carbon, and then we have a bond to the hydrogen, and it's going to have 2 lone pairs of electrons. So they didn't even show it on this Lewis dot diagram, right? But you could draw it in so that you know that oxygen has those lone pairs. All right, let's see, and that's it.